All right, so we are recording. So today we're looking at multivariable. So we're looking at 3 variable equations. Okay. And I know the book does it a little bit different where they look at backwards substitution, things like that. And I like elimination personally. That's what I choose to do every single time. So I'm going to try to make it as easy as possible for you, so that it makes it just easier, instead of sitting there kind of thinking and getting all lost in all these problems and things like that. Okay, so system with 3 variables, we got an equation, an example here for you. When it's in row echelon form, okay, if you notice, one of the variables is solved for it, so that when you have z is 2, you can take that and plug it in, and then take that and plug both the z and the y into the first one to find your x. Okay. Row echelon, okay, just means that it has a stair-step pattern. Stair-step pattern with leading coefficient of 1. Okay, so if you look at all of these, we have a leading coefficient of 1, and then it stair steps, as we said, going backwards to solve it. And that going backwards is just back substitution. So if it's set up in row echelon, like I said, it's pretty basic to solve for you. Now, if it's not in row echelon, I tend not to solve it that way or set it up that way. I tend to match up all the x's, all the y's, or all the z's and do it as elimination, because I think that's just a little bit easier, especially when you're going to teach it. But let's go ahead, if it is in row echelon, let's go ahead and solve this, okay? Since one variable is already solved for, like I said, it's easy to go to the next equation because there's only 2 letters there, and we already know what z is, so we can plug z into that and find our y, correct? So if we look at that, we could do y plus 3 times my z, which is 2, equals 5, and we could solve from that. So 3 times 2 is our 6. And then subtract the 6, so y equals -1. So now if I know z, I know what y is. I can now plug z and y into that first equation to find my x. Okay, so we don't know what x is. Minus 2 times my y, which is -1, plus 3 times my z, which is 2, would equal my 9. And then go from there and solve. Okay, so -2 and a -1 make?
-3.
Try that again.
Wait, what did you say?
-2 times -1?
-2 times -1? 2.
2, okay.
I thought you said -2 plus
and a -1. Yeah, I said but I get you. Equals 9. And then we have like terms. 2 plus 6 is?
8.
8. And then subtract the 8, so x equals?
1.
So we know what x is, we know what y is. What is that point of intersection of all 3 planes?
1, -1, 2.
Yep, -1 and 2. So if it is set in row echelon, it makes it really, really easy because it's just a matter of plugging in, finding your variable. Okay, not a lot of thought to that. Now, our elimination sense, elimination is operations that produce equivalent systems. Okay, so each of the row operation will produce an equivalent system of equations. Okay, and how we solve that is we're going to interchange the equations, 2 equations. We will multiply one of the equations by a non-zero constant, just like we did in elimination with 2 variables, as we multiplied the equation by a constant. And then once we did that, we were able to add the equations so that we can replace the later equation to find the next variable, right? Mm-hmm. Now, when you look at this, and most books always say multiply just one of the equations, I tend to, if there's 3 variables, I tend to match up either all my x's, all my y's, or all my z's first, so that you can sit there and just add your equations from there, so that you don't have to keep multiplying different things from that. So let's go ahead, and if you look at example 1 is just a 2 variable. So let's go ahead and review that. And you can't see that. So let's go ahead and review that. So we have 3x minus 2y equals -1, x minus y equals 0. So again, as we know, we need same number, opposite signs. So which ones would you guys like to match up? The x's or the y's?
Probably the y's.
Y's. So what would I multiply the second equation by then?
-2.
-2. And why did you choose a negative?
Because it's x minus y on the second equation.
Right, and we want it to be a
positive.
Positive. Good. So -2 times x is your -2x. -2 times a -y is a
Positive 2y.
And -2 times 0?
0.
And now since we have the same number, opposite signs, we can go ahead and add the equations, right? So 3x plus -2x is
X.
-2y and 2y.
Cancel.
And then we have -1. So now we know what x is. And now we can just find our y, right?
Mm-hmm.
So do you want to plug it into the first one, the second one?
Second one.
Second one. All right. So x is -1 minus y equals 0. So normally we'd add the 1, divide by -1. But how would I move the y to the other side?
Add it.
Just add it. So would I get -1 equals y?
Yes.
Yeah. So we have the point of intersection of -1, -1. All right. So two-step elimination, do we understand that?
Mm-hmm.
Okay, good. Now, as we look at part A and C here, okay? So, and there's a B, but we'll look at these ones. What we're gonna do is, and again, I find it easier just to do this, and I taught it to my niece down in Fishers the other day to help her, and she thought it was a lot easier this way too. When we look at this, I tend to match up all 3 of those equations, and I at least need one variable to be opposite signs. Okay, so yes, we have 3 equations here. Okay, out of these 3 equations, we need just one of them to be opposite signs. Okay, the other 2 can be the same sides. We just need one of them to be opposite. Okay, so if I'm looking at here, do you guys want to match up the x's, the y's, or the z's? It's 100% your choice.
X's look the easiest to
Okay,
me, but I might be wrong.
Honestly, that's what I did also. Okay, so if I'm going to match up the x's, what can 1, -1, and 2 both go into?
2.
2. So I can multiply this first equation by
2.
The second equation by
-2. Or
okay,
no, yeah, 2.
I'm going to keep it a +2 because that takes care of my 1 negative, right?
Mm-hmm.
Okay, and then the bottom one is already 2x, so I don't need to worry about that. Okay, is everyone okay with that?
Mm-hmm.
All right, so now let's go ahead and just write that. What's 2 times 2x, or 2 times x? Sorry,
2x.
2 times -2y.
-4y.
2 times 3z.
6z.
And then 2 times 9.
18.
Good. All right, so there's my first one. The second one, 2 times -x.
-2x.
2 times 3y.
6y.
2 times, there's no z, right? So then 2 times -4 is?
-8.
-8. Okay. And then our last one is just the exact same. All right. So now, to be able, we would then add our equations, right? So to add our equations, we need 1 to be positive, 1 to be negative. So I'm going to add these first 2 equations. And why would I add these first 2 equations? Because what would happen to those x's?
They would cancel.
They would cancel out. So when I add those, what do we get? 2x plus a -2x.
Cancels.
-4y plus 6y.
2y.
2y. And then we have 6z, right? Equals what's 18 plus -8?
10.
Good. All right, you guys okay with that? Now, we have not used this third equation. So I need to add this third equation to one of the first one or the second one. Since 2x is positive, I need to add it with the -2x, right?
Mm-hmm.
So I'm now going to add the bottom 2 equations. Okay, so let's go ahead and add the bottom 2 equations. So -2x and 2x.
Cancels.
Cancel. 6y and negative 5y.
Y.
Y. And then we have 5z equals, what's negative 8 plus 17?
9.
All right. Now, are we back to a two-step,
Yes.
two-variable system?
Yes.
Yeah. So let's go ahead now and solve for either y or z, your choice.
I would go with the Y's.
X's or y's, I would choose the y's also. And the reason why is because I just have to multiply this second equation by what?
Negative 2.
Negative 2. Good. So now the first one, I'm just going to rewrite again. The second equation, what's negative 2 times y?
Negative 2y.
Negative 2 times 5z.
Negative 10z.
And negative 2 times 9.
Negative 18.
Okay. And now we're going to add those equations, right?
Mhm.
So negative 2y and 2y.
Cancel.
6z and negative 10z.
Negative 4z.
10 and negative 18.
Negative 8.
Okay. And then how do I solve for z?
Divide by negative 4.
So z is
2.
2. So now we know what z is. Now we can find what?
Y.
Y. And if we're finding y, I would choose either the first one or the second one here, right?
Mhm.
I don't want to go back to the original because the originals have x's in it, right? And we don't know what x is. So I always go back to one that has a y or z. So do you want to do the blue or the dark green?
Dark green.
So y plus 5 times, what's my z?
2.
2. All right, so then 5 times 2 is?
10.
10 equals 9. So y would equal?
Negative 1.
Negative 1. So now we know z, we know y. Now we can find?
X.
X. So I'm going to go now back to the original 3 because now that's where my x's are. And do we want to plug into the first one, the second one, or the third one?
Second one.
I'd probably choose the second one. Why?
Because it doesn't have the z and it already has.
Z. If it did, it's okay. We could plug it in. But
right.
That's a good choice. I would choose that one too. So negative 2, we don't know x, plus 6 times, what's my y?
Negative 1.
Negative 1 equals negative 8. So what's 6 times negative 1?
Negative 6.
Equals 8. Negative 8. Add the 6 over, and we get negative 2x equals?
Negative 2.
Yep. And divide by negative 2, so x is?
1.
So now we know x, we know y, and we know z. So what is my point of intersection?
1, negative 1, 2.
Perfect. And there you go. Did you guys remember that from Algebra 2 last year?
Mm-hmm.
Okay. Does that make a little bit more sense to you?
Yeah.
Okay. Like I said, I like matching them up right off the bat so that you know just to add and subtract from there, or add.
Mm-hmm.
Okay. All right. So let's look at the next one. Okay. All right. So we have X's, Y's, Z's. Which one do you guys want to match up in this sense? Okay. Again, it doesn't matter. We can do the X's, we can do the Y's, we can do the Z's. It's 100% up to you.
Z's.
X probably.
X. Okay, I heard X's, I heard Z's. I probably would choose X's over the Z's. And the only reason being is because we have 1, 1, and 2. So I only have to multiply 2 equations. If I would do the Z's, I'd have to match up the 1, 2, and 3. So wouldn't I have to multiply every single one of those equations?
Mm-hmm.
Yeah. So I'm going to choose X's too. But again, it doesn't matter. You could do the Z's, JD, if you want to see if you get the same answer. So what can 1, 2, and 1 all go into?
2.
2. Okay. Now we need to make one of these negatives. Do you want the first one to be negative or the third one to be negative? Sorry, or the middle one?
First.
Let's go third.
All right. So we're gonna. That's funny. Let's go first. Let's go third. It doesn't matter. We'll multiply the first one by negative 2. The last one will be our positive 2. Okay. So what's negative 2 times x?
Negative 2x.
Negative 2 and a negative 3y?
6y.
Negative 2 and z?
Negative 2z.
Equals negative 2 and 1.
Negative 2.
The second one is staying the exact same. And then the third one, 2 times x.
2x,
2 times 2y,
4y,
2 times negative 3z,
negative 6z,
and 2 times negative 1.
negative 2.
All right. So now to be able to add, we need to have a negative and a positive, correct?
Yes.
So I'm going to go ahead and take that sheet off. This is kind of in my way now. All right. So we can add the first one with the second one, right?
Mm-hmm.
All right. So let's go ahead and add these ones. Negative 2x and 2x.
Cancel.
Cancel. 6y and negative 1y.
5y,
Negative 2z, negative 2z.
negative 4z,
And negative 2 and 2.
0.
All right. Now, we haven't used the last one. And the last one has a positive 2x. So I need to add that with which equation? The first one or the second one?
First one.
The first one. So I'm going to add these two. And if it helps, I'm going to rewrite that first one underneath so that I can see it a little bit better for you. All right. So now we're adding these two. So what's 2x and negative 2x?
Cancel.
Cancel. 4y and 6y.
10y,
Negative 6z and negative 2z
negative 8z,
equals negative 2 and negative 2.
negative 4.
Negative 4. Okay. You guys okay with that? Now, we just have y's and z's. So we need to either match up the y's or the z's. Your choice. Which one would you guys like to match up?
Z's.
Z's?
Z's, yeah. It really doesn't matter because, I
It
mean,
really doesn't matter. It doesn't. So
because, I mean,
what can,
you're either way, you're going to have to multiply by 2
Negative.
anyway.
right,
negative
a
2.
positive or negative 2?
Negative 2.
Negative 2. And why a negative 2?
Because the bottom one is already positive.
No, the bottom one's
And-
negative, so we need to make
Well,
it a
yeah, yeah,
right?
and
Or
it'll change.
if you looked at the y's, yes. So
Yeah.
again, it doesn't matter.
Yeah, in general, I mean, yeah.
Okay, perfect. Yeah, we just needed the opposite signs is the main thing. So negative 2 times 5y,
Is negative 10y,
negative 2 and negative 4,
8y,
z. And then negative 2 and 0,
z, yeah.
and then rewrite the bottom one. All right, let's go ahead and add. What's negative 10y and 10y?
Cancel. They both cancel.
8z, negative. So what's on that side?
0.
0.
No
And what's
solution.
0 plus negative 4?
That's going to be negative 4.
Now, we don't have a value, right?
Right.
So, or a variable. So we either have no solution or infinitely many. So which one would this one be?
No solution.
No solution. Now, is this consistent or inconsistent?
Inconsistent.
This is inconsistent. Why?
Because it
There's
would be
no point
parallel
in
lines.
common. Yep. No point in common. Just the reminder from 7.2, I think.
Mhm.
All right, let's look at B now. This one's kind of nice because you got some
Okay.
missing variables in the last two equations, right?
hmm
So that's really nice. So if you look at the middle one, we have the y and the z and no x. And what do you notice about these x's from the first equation and the third equation?
They're opposite.
They will cancel out if we add these two, right?
Mhm.
So what I'm going to do is I'm going to add this first one with this last one and tell me what you get. What's x plus negative x?
Cancel.
Cancel. Y plus 2y.
3y.
3y. Negative z plus nothing.
Negative 3z.
Negative 3z. Yeah, sorry, I forgot the. And then negative 1 and 1.
0.
All right. Now, the second one, we don't need to add it with anything because isn't there already an x missing?
Right.
Yeah, so I can just rewrite this equation of y minus z equals 0. Now, could we solve for either y or z here?
Mm-hmm.
So what do you want to match up, the y's or the z's?
Y's.
Y's, okay. What would I multiply the bottom one by?
Negative 3.
Negative 3. So that we have opposite signs. So I'm going to rewrite the first one.
I already know what this one is.
Uh-huh. All right,
Infinitely
-3
many.
times y. 3y. -3 times negative z.
Plus
Positive
3y.
3z.
Or 3z. Ugh.
And equals, I know we keep doing that. All right, what happens?
They both cancel.
They both cancel. So we
It's
have
infinitely
0
many.
equals 0. So this one,
Infinitely many.
infinitely, that's an L, many. So is this one consistent or inconsistent?
Consistent.
Consistent, because at least one solution, right?
Mhm.
Yeah. It's a refresher. Great. Any questions with this so far? Are we getting this understanding okay?
Mhm.
All right, good. All right, now let's throw it into our applications, your favorite story problems.
So many words.
So many words, we don't like it. But you want to know the good thing about this?
Hmm.
They give you an equation.
Oh,
And if they
good.
give you an equation, we're probably going to
Use that equation.
use that equation. Exactly. All right. All right. So let's go ahead. The height at time t of an object that is moving in a vertical line with consistent acceleration a is given by the position equation. Okay. So we have, and I'm going to rewrite it because it's kind of blurry. S equals 1/2 a t to the second squared plus VO t plus SO. Sure. All right, where S is the height in feet. Okay, so this is the height in feet. A is the acceleration per second in feet per second. T is the time in seconds, and VO is our initial velocity. Okay, at T is 0. And S sub 0 is the initial height. So the initial height is where we start at, right?
Mhm.
All right. Find the values of A, VO, and SO. So that's like our X, our Y, and our Z, right? Our X and our Y are Z. When S is 52 at T is 1, S is 52 at T is 2, and S equals 20 when T is 3. And interpret your results. Okay. That's a lot of words, isn't it?
Yes, it is.
Okay. But the key thing is we need to find what? We need to find A, we need to find VO, and we need to find SO, right? So we need to find A, VO, and SO. So guess what? They gave us what an S is and what our T is, don't they?
Mm-hmm.
So we can go ahead and find those values using elimination, right? So let's go
Yes.
ahead and let's see the first thing. If S is 52 at T is 1, could I plug 52 into S and plug 1 into T and write an
Yes.
equation? Yeah. So let's kind of do that. So when T is 1, my S is what?
52.
Equals 1/2 times A, which we don't know. And what is my T?
1.
1, yep, squared, plus VO times what's my T?
1.
1 plus S sub 0, right?
Mhm.
So let's go ahead and simplify that to a little bit better for me, okay? And do you mind if I put the equal sign on the other side of the equation? I don't like
Go
it.
ahead.
I don't like it on the left. That kind of freaks me out. All right, 1 squared is
1.
A 1.
1. 1 times 1/2 is just
1.
half, right? So we have 1/2 A. You guys okay with that?
Mhm.
What's 1 times VO?
VO.
VO plus SO equals our
52.
52. Hey, there's our first equation. Can we do it when S is 52 at T is 2?
Yes.
Yeah. So now when T is 2, let's write our equation. 52 is my S equals 1/2 times A times what's my T now?
2.
2 squared plus VO times what's my T?
2.
Plus S sub 0. All right. And let's simplify. So again, I'm putting the 52 on the other side. That's weird to me. All right. 2 squared,
4.
4. And what's 1/2 of 4?
2.
2.
We have 2A plus what's 2 times VO?
2 VO,
2 VO plus SO. Right? And then the last one, S is 20 when T is
3.
3. Yeah. So my S is 20, and now we're plugging 3 in for T. Okay. So again, I'm putting the 20 on the other side. All right. What's 3 squared?
9.
9. 9 times a half is just 9
4
over
and a half.
2. Yeah, 4 and a half, but can I leave it as 9 over 2?
Yeah.
All right. Plus 3 times VO plus SO equals 20. Okay. All right. You guys okay with that?
Mhm.
All right. Now, we got to match up either my A's, my VOs, or my SOs, right? What's going to be easier?
SO.
SOs. Why?
There's no number in front of them.
There's no
Oh,
number in front of them. The only thing is we have all 3 positives, so one of these has to be
Negative.
negative. Okay. Now, do you guys want to deal with those fractions or get rid of them at the same time?
Get rid of them.
I would get rid of them, okay? Because if I multiply the first one and the second one by 2, wouldn't that get rid of my fraction?
Mhm.
Yeah. So let's go ahead and match up these S's, not by 1, but let's match them up by
2.
2. And the only reason why I say let's do 2 is because then we can get rid of the fractions at the same time. Okay. But if we have to multiply these by 2, I'm still going to have to multiply the middle one by something too, won't I?
Mhm.
And what would I have to multiply the middle one by?
-1.
Negative 1. Yeah.
Close. I would
1.
choose -2. Why did I have to do -2 instead of -1?
Oh, because the S's are going to be 2.
Because now the S's are going to be
Yeah,
2s
okay.
and not 1s
Oh.
anymore.
Huh.
Does that make sense?
Mm-hmm.
Yeah.
All right, so let's multiply the first one. What's 2 times a half?
1.
1.
1. A. 2 times VO,
2 VO.
2 VO.
2 times SO,
2 SO.
and 2 times 52.
104.
104.
All right, let's multiply by -2. -2 times 2A.
Negative 4A.
Good. -2 times 2VO.
Negative 4 VO.
Good. -2 times SO.
Negative 2 SO.
And -2 times 52.
Negative 104.
And then the last one. What's 2 times 9/2?
That's going to be 9.
9.
Right, good. 2 times 3VO.
6 VO.
2 times SO.
2 SO.
And 2 times 20.
40.
All right. Good. So now we have a +2 SO and a -2 SO. So I can add the first 2 equations, can't I?
Mhm.
Yep. So let's go ahead and add. What's A plus -4A?
Negative 3A.
-3A, good. What's 2VO plus a -4VO?
Negative 2 VO.
2 SO and -2 SO,
Cancel.
cancel. And 104 and -104,
Cancel.
cancel. Good. Now, what equation haven't I used?
The third one.
The third one. And so since it's a +2 SO, which one am I going to add it to? The first one or the second one?
The second equation.
The second one. So I'm going to add these 2. Okay. So what's -4A plus 5A or 9A?
5A. 5A.
I said the answer. -2VO plus 6VO.
You mean negative 4 VO?
Yep, that's what I meant. So -4 plus 6.
2 VO.
I can't even read. -2 SO plus 2 SO.
Cancel.
Cancel. Equals, and then -104 plus 40.
-64.
Good. All right,
That number.
that number. All right, now, what do you notice about the A's and the VOs?
VOs cancel.
Yeah.
The VOs
VO.
cancel, so I don't have to multiply anything, do I?
No.
No, so let's go ahead and just add these equations now. And what do we get? Negative
2A
A plus 5A, 2A. The VOs
equals
cancel,
negative 64.
and we get negative 64. Good. So divide by A, so what is my A?
Negative 32.
Hey, we found A. Now, what's the next thing we can find? Can we find
VO.
VO or SO? The VO. Which one do you want to plug into? The first one or the second one?
Probably the first one.
I'd probably pick the first one too. So negative 3 times what's my A?
Negative 32.
Minus 2VO equals 0. What's negative 3 and negative 32?
96.
96. Minus 2VO equals 0. Then what?
Subtract 96.
Yep.
Yes,
So we get
subtract.
negative 2V equals negative 96. Then,
Divide by negative 2.
and we get what?
48.
48. Good. So now we know A, we know VO. So now we can find.
So.
Oh, that sounds funny. All right. Which one do we want to plug into for SO? The first one, the second one, or the third one?
Second one.
Second.
I would choose second just so you don't have to deal with fractions. But does it matter?
No.
No.
All right. So 2A, and what's my A?
Negative 32.
Plus 2 times what's my VO?
48.
Plus SO equals 52. So let's do our math. What's 2 times negative 32?
Negative 64.
64. 2 times 48
96.
plus SO equals 52. And what's negative 64 plus 96?
32.
32 plus SO equals 52. So SO equals
20.
20. So did we find our A,
Yes.
our VO,
Yes.
and our SO?
Yes.
Mhm.
Yeah. So we found what's our initial velocity? What was my VO?
48.
Yeah, 48. So this is my initial velocity. So that's where we start at our speed, right? Our, what does S stand for? The SO. I don't know where it's all in there. I can't my writing right now. That's kind of blurry to me. All right. Any questions with that one? So even though we had that fraction, it wasn't as bad as you thought it was going to be, did you?
No.
No. All right. So now, example 5. Find the quadratic equation of y equals ax squared plus bx plus c that passes through the points of negative 1, 3, 1, 1, and 2, 6. Ooh, it seems kind of confusing, doesn't it?
Yeah, kind of.
Yeah, kind of. Well, what do we know about points? Points
They're
are
points.
always labeled what?
X and Y.
X and Y. Yeah, thanks. X and Y. So we have how many X and Y values?
3
We have
each.
3 XY values. And could I plug those in and set up 3 different equations to
Yeah.
find out my A, B, and C, which are my 3 unknowns?
Mm-hmm.
Yeah, I think we can do that. So to be able to write this equation, we need to know A, B, and C, because those are all numbers, right?
Yes.
Yeah. And we know what X and Y is, so we can plug those in and then get our 3 unknown equations with our 3 unknown variables and just do exactly what we did before. Okay. So let's go ahead and first do the point negative 1, 3. Okay. So let's plug it in to write our equation. What's my Y coordinate?
3.
3 equals A. We don't know yet. What's my X?
Negative 1.
Negative 1 squared plus B. We don't know. And what's my X?
Negative 1.
Plus C. All right. And let's simplify this like we did up top. These are easier letters.
Oh,
All right. So we get 3. I'm going to put on the right side. I like that better. What's negative 1 squared?
1.
1. 1 times A.
Okay.
A.
What's B times negative 1?
Negative B.
n plus c.
I remember this now.
You remember this now? Yeah. So there's one equation. Let's do the next one. Let's do the 0.11. What's my y?
1,
One.
A, we don't know. What's my x?
1,
Plus b times, what's my x?
1.
Plus c. So it equals 1.
A
1
plus B
squared.
plus C.
So a plus b plus c. Good. All right. And then our last point of 2, 6. So what's my y?
6,
Equals a times what's my x
2,
squared plus b times x
2,
plus c. So what do we get? Equals 6. 2 squared,
4,
4.
4. So we have
4A.
4a. 2 times b
2B.
and plus c. All right. There's your 3 equations with your 3 unknowns. Now,
Yep.
here's my question. Do you want to match up the a's, the b's, or the c's?
C's.
I would do the c's too because they're all the same number. The only thing is we don't have a negative. So is there an equation that you would want to multiply by -1?
Second.
The second? Okay. And if I multiply this by -1, doesn't it just change the sign to everything?
Mhm.
Mm-hmm.
So can I go ahead and just write it like that so I don't have to put a whole nother line?
Yeah.
Okay. So now we have a positive c, we have a negative c. So can I go ahead and add these first 2 equations?
Yeah.
Yeah, so let's go ahead and add those first 2 equations. So it's a plus negative a.
Cancel.
Cancel. What's negative b plus negative b?
Negative 2B.
2b. What is c plus negative c?
Cancel.
And what's 3 plus -1?
2.
2. Huh. They only have one variable.
Wow.
So what does that mean?
We can find B.
I can solve for b's. And how do I solve for b?
Divide by -2.
So b equals
-1.
1. All right. Hey, we already solved 1. But now we use the first equation and the second equation. So now I have to use that third equation. And the third equation, since it's a positive c, which one would I add it to? The first one or the second one?
Second one.
Second one, because that's their negative. So let's go ahead and add these 2. What's -1a plus 4a?
3A.
What's a -1b plus 2b?
B.
B. Negative c plus c?
Cancel.
Cancel. And then -1 plus 6?
5.
5. All right. Well, now we have 2 letters, but we already know what b is, don't we?
Yep.
And what is my b?
-1.
-1. So could I plug -1 in here and find my a?
Yeah. Yeah.
So how do I move the -1 over?
Add it.
Add it. And we get 6.
6.
Divide by a. So a equals
2.
2. Divide by 3. I said a. Divide by 3. So now we know what a is. We know what b is. Now we can find
C.
c. So go back to the equations that have a, b, and c in here. And again, you can look back to the original without the negatives. Do you want to use the first one, the second one, or the third one?
Second.
The second one? Okay, so
I
my
like the first
original,
one on that one.
okay. That's fine. Go ahead and use that first one. That's up to you, JD. Okay. It really, honestly, guys, it doesn't matter. I'm going to use the orange one just because that's what I heard first.
Okay.
And my first one was a plus b plus c equals 1. Okay. What's my a?
2.
2. What's my b?
-1.
Plus c equals 0. So 2 minus 1
1.
plus c equals, I don't know why I put 0 there. That should be a 1. 1. And then c equals
0.
0. That's why I put 0. But all right, so now we know a, we know b, we know c. Can we write our equation, my quadratic equation?
Yes.
Yes. Remember, my quadratic equation is y equals ax squared plus bx plus c. We know our a, b, and c, so can I plug them in?
Yeah.
Yes. So y equals, what's my a?
2.
2. So
2x squared.
plus what's my b?
-1.
Negative 1x plus, what's my c?
0.
0. But now, is this cleaned up?
No.
No, let's clean that up. Y equals 2x squared. Instead of plus a
Minus
negative 1, we
x.
should put minus x. And do I need the plus 0?
No.
Nope.
So this would be my quadratic formula through those points. And if we really need to find the vertex, we could, all that fun stuff, but we're not doing that. Okay. All right, and that is it. I'm going to go ahead and stop recording real quick. All right. Any